Module 4, WAN Technologies. WAN Concepts and Technologies. Wide Area Network, WAN, refers to a network that spans a large geographical area and connects multiple local area networks, LANs, or other networks together. WANs are typically used to connect remote locations, such as different offices or branches of an organization, over long distances. Here are some key concepts and technologies related to WAN. 1. Circuit-switched networks. Circuit-switched networks are traditional telecommunications networks that establish a dedicated communication path between two endpoints for the duration of a session. This path remains reserved for the entire duration of the session, even if no data is being transmitted, resulting in inefficient use of bandwidth. Examples of circuit-switched networks include plain old telephone service, POTS, and integrated services digital network, ISDN. 2. Packet-switched networks. Packet-switched networks, on the other hand, divide data into smaller packets and transmit them separately over a shared network infrastructure. Packets can take different routes to reach the destination and are reassembled at the receiving end. This allows for more efficient utilization of bandwidth, as multiple packets from different sessions can be transmitted over the same network simultaneously. Examples of packet-switched networks include the Internet Protocol, IP, networks, such as the Internet. 3. Leased lines. Leased lines are dedicated communication lines that are rented from a service provider for exclusive use by an organization. Leased lines provide reliable and secure connections, but they can be expensive, especially for long distances. These are some of the key concepts and technologies related to WAN. WANs play a critical role in connecting geographically dispersed locations and enabling organizations to communicate and share data efficiently over long distances. The choice of WAN technology depends on factors such as the distance between locations, bandwidth requirements, reliability, security, and cost considerations. Proper design, configuration, and management of WANs are essential for ensuring reliable and efficient communication across remote locations. WAN connection types: leased lines, frame relay, MPLS, and VPN. There are several different types of wide area network, WAN, connections that organizations can use to connect remote locations. Here are some commonly used WAN connection types. 1. Leased lines. Leased lines are dedicated communication lines that are rented from a service provider for exclusive use by an organization. Leased lines provide reliable and secure connections with guaranteed bandwidth and low latency. Leased lines are typically used for high-performance and critical applications where consistent performance and reliability are paramount. However, leased lines can be expensive, especially for long distances, and may require significant upfront costs for installation and maintenance. 2. Frame relay. Frame relay is a legacy WAN technology that uses virtual circuits to establish connections over a shared network infrastructure. Frame relay is based on the concept of permanent virtual circuits, PVCs, which are pre-configured connections between remote locations. Frame relay provides flexibility in terms of bandwidth allocation and is typically used for non-critical applications where cost is a consideration. However, frame relay has largely been phased out in favor of newer technologies such as MPLS and Ethernet. 3. MPLS, multi-protocol label switching. MPLS is a widely used WAN technology that uses labels to identify and route packets over a network. MPLS provides a scalable and flexible solution for connecting remote locations securely. MPLS networks are typically managed by service providers and can offer quality of service, QoS, capabilities for prioritizing different types of traffic. MPLS is commonly used for enterprise networks and offers a reliable and secure option for connecting geographically dispersed locations. Each WAN connection type has its own advantages and disadvantages, and the choice of technology depends on factors such as the organization's requirements for performance, reliability, security, scalability, and cost considerations. Leased lines, frame relay, MPLS, and VPN are some of the commonly used WAN connection types, and organizations need to carefully evaluate their needs and select the appropriate technology to meet their specific requirements. WAN encapsulation protocols, HDLC, PPP, and PPPoE. WAN encapsulation protocols are used to encapsulate and transmit data packets over wide area networks, WANs. Here are some commonly used WAN encapsulation protocols. 1. HDLC, High-Level Data Link Control. HDLC is a synchronous data link layer protocol that is commonly used for point-to-point connections, such as leased lines. HDLC provides reliable and efficient data transmission by using acknowledgements and error-checking mechanisms. HDLC is a simple and widely supported protocol, but it is typically used in legacy networks and has limited flexibility compared to newer protocols like PPP. 2. PPP, Point-to-Point Protocol. PPP is a widely used encapsulation protocol for establishing point-to-point connections over WANs. PPP provides authentication, error checking, and negotiation capabilities, making it more feature-rich and flexible compared to HDLC. PPP supports multiple network layer protocols, including IP, Internet Protocol, IPv6, Internet Protocol version 6, and others, allowing for greater interoperability. PPP is commonly used in WAN connections that require authentication, such as dial-up connections and some broadband connections. 3. PPPoE, Point-to-Point Protocol over Ethernet. PPPoE is a protocol that allows PPP to be used over Ethernet networks. PPPoE encapsulates PPP frames within Ethernet frames, making it possible to use PPP over Ethernet-based WAN connections, such as DSL, digital subscriber line, and cable modem connections. PPPoE is commonly used in broadband networks where the service provider requires authentication of the user's connection. Each WAN encapsulation protocol has its own advantages and use cases. HDLC is a simple and widely supported protocol suitable for legacy networks or point-to-point connections where advanced features are not required. PPP is a more feature-rich and flexible protocol that supports multiple network layer protocols, making it suitable for various WAN connections. PPPoE is specifically designed for Ethernet-based networks, such as DSL and cable modem connections, where authentication is required. Organizations need to choose the appropriate encapsulation protocol based on their specific WAN requirements and the capabilities of their network equipment and service provider. Module 5, Infrastructure Services. DHCP and DNS. DHCP, Dynamic Host Configuration Protocol, and DNS, Domain Name System, are two essential networking protocols that play critical roles in the operation of modern computer networks. DHCP is a network protocol that allows devices on a network to dynamically obtain IP, Internet Protocol, addresses, as well as other network configuration settings, such as subnet mask, default gateway, and DNS server addresses. With DHCP, network administrators can manage and assign IP addresses to devices on a network automatically, eliminating the need for manual IP address configuration. DHCP simplifies the process of IP address management and helps ensure that devices on a network have unique IP addresses and correct network configuration settings. In summary, DHCP is responsible for automatically assigning IP addresses and other network configuration settings to devices, while DNS translates domain names into IP addresses, allowing devices to locate each other on the Internet. Together, DHCP and DNS are critical protocols for the functioning of modern computer networks and the Internet as a whole. NAT and PAT. NAT, Network Address Translation, and PAT, Port Address Translation, are two techniques used in networking to conserve IPv4, Internet Protocol version 4, address space and enable communication between devices with private IP addresses and the public Internet. NAT is a technique that allows devices with private IP addresses to communicate with the public Internet. Private IP addresses are reserved IP address ranges that are not routable on the Internet, as defined by the RFC 1918 standard. NAT allows devices on a private network to share a single or a pool of public IP addresses when communicating with the Internet. The NAT device translates the private IP addresses of the devices on the private network into a public IP address before forwarding the traffic to the Internet. This allows multiple devices on a private network to share a limited number of public IP addresses, conserving IPv4 address space. HSRP and VRRP. HSRP, Hot Standby Router Protocol, and VRRP, Virtual Router Redundancy Protocol, are two network protocols that provide redundancy for default gateways in a local area network (LAN) environment. They are used to ensure high availability and reliability of the network by allowing multiple routers to work together as a virtual router, providing a redundant gateway for devices on the LAN. HSRP is a Cisco proprietary protocol that provides redundancy for the default gateway IP address on a LAN. It allows two or more routers to share a virtual IP address and MAC address, acting as a single default gateway for devices on the LAN. One router is designated as the active router, while the others are in standby mode. The active router forwards traffic on behalf of the virtual IP address, while the standby routers monitor the health of the active router. If the active router fails, one of the standby routers takes over as the new active router, ensuring continuity of network connectivity. VRRP, on the other hand, is a standard-based protocol defined in the RFC 5798 that provides similar functionality to HSRP. VRRP allows multiple routers to work together as a virtual router with a shared virtual IP address and MAC address. Like HSRP, one router is designated as the active router, while the others are in standby mode. The active router forwards traffic on behalf of the virtual IP address, and the standby routers monitor the health of the active router. If the active router fails, one of the standby routers takes over as the new active router, ensuring continuous network connectivity. Both HSRP and VRRP provide redundancy for the default gateway in a LAN environment, ensuring that devices on the LAN can maintain connectivity even if one of the routers fails. They are commonly used in enterprise networks, data centers, and other critical network environments where high availability and reliability are important requirements. While HSRP is Cisco proprietary, VRRP is an industry-standard protocol that is supported by various networking vendors, making it more interoperable across different networking equipment. Thanks for watching. For more information, like, comment, and subscribe our channel.